Yeah. Brought home and gave it to the brought bros. Then she had like the princess crown.
Crustables.
I was a cheese house. Yeah, I was supposed to cheese house. I know.
I wish I had more than 19 days of school left, and I realized that with you seniors, I've really only got about 13 or 14. So, man, I wish that I'd budgeted my time a little bit better because I'm going to try to give you the most comprehensive look at conic sections that I can, while also respecting the fact that that board behind me does not lie. 19, 18 days is not a lot of time. So I'm just going to salvage what I can out of the time that I have left with you. But there's a whole series of these items called conic sections in mathematics. And tomorrow, perhaps, unless today is better and there's time, but I'll show you where the conic sections come into existence. And once you see like a visual aid of how they exist, then you'll realize why we call them conic sections. But there are essentially four flavors of conic sections. There's parabolas, which is what we're going to do like today and tomorrow. And then there's ellipses, which are like take a circle and like pull it from the sides, that you get what's called an ellipse. We sometimes casually call them ovals, which is pretty ghetto. So in ellipse, there's circles, which is just an ellipse that didn't get stretched. And then there's hyperbolas, which is it's like two sort of opposing parabolas. They can go left and right, or they can go up and down. But the only one we're going to focus on today, and quite frankly, maybe for the rest of this week, is parabolas. But we're going to take a different look at parabolas than what you're used to. So like the Algebra 1, Algebra 2 version of parabolas isn't really what we're going for here today. So I think, quite frankly, because you're all pretty good math learners, the hardest part of this is going to be if I can somehow get this first part to come out of my mouth correctly. So what I need to get across to you first is the definition of what a parabola is. In algebra or algebra 2, when we first talked about parabolas, we just learned it as the graph of anything with x squared. So it was a pretty could someone, I'm sorry. Thank you. Whoa. Thank you so much. So we've always known parabolas from one perspective. And back in algebra 2, probably algebra 2, not algebra 1, I showed you how to graph parabolas, vertex form, standard form, all that stuff. So today, like I said, we're completely changing our approach. And if you wanted a better explanation than this guy is about to give you, Sal Khan Academy guy, does a really good explanation. You'll find all sorts of good YouTube videos, resources out there to explain what I'm potentially going to ruin right now. But anyways, your previous understanding of a parabola, again, was just something that we got when we graphed y equals x squared. Today, we have to sort of change our thinking. And I'm going to give you a definition and give you like you should write this down kind of speech. But I think before we do that, I want you to see sort of how a parabola comes into existence. So I'm going to start with a line. And so I'm just going to sketch this on notebook paper just like you would. So we're going to start with a line. And this part of the lesson, I got to be honest, isn't as important as just, a lot of you guys are just like, show me how to do it so I can get it done kind of thing. And this really isn't that part of the lesson. This is the kind of behind the scenes look at what the definition of a parabola is. And then there's going to be another point. And I want to be specific with these numbers. So like this, well, bless you, is going to be -1. And then let's go up to 3. And let's put a point right up above it. So never before has a parabola been talked about in your presence like this, but a parabola from this point on is going to be known as the set of all points equidistant from a point on a line. I'll write that down for you. So a parabola, by definition, is the set of all points that are equidistant. If you don't like that word, you can just write the same distance. I just think it sounds fancier and pretty dope to say equidistant So equidistant from a point and a line. There is about a 72% probability that in about 3 minutes you're going to be a little bit confused. And by a little bit, I mean potentially a big bit. So that's okay. Just write it out. And again, bear in mind that this part isn't so much mechanically as far as like, how do I get this done? This isn't really the meat and potatoes part of this. But what you have here is a point and a line. And this point is going to be what we come to know as, get used to this because you're going to hear this word a lot in the next week or two. That point's called the focus. And this line down here, I would say, do you want to guess what it's called? But that would be an exercise in absolute just weirdness. It's called the directrix. So if you were to go right now onto the internet or to YouTube or anything like that and search focus and directrix, you would immediately 100% get about 10,000 matches for conic sections. So conic sections, these words apply to a parabola. You're going to see the word focus or foci, the plural of focus, when we talk about hyperbolas and ellipses as well. And same with directrix. And so these terms are pretty unique or native to when we talk about conic sections. Anyhow, here comes the will you understand this part of this. So I wish you luck and I wish me luck. I'm going to start with the most obvious point in the world that is the same distance from the red point and the yellow line. And I hope and pray that you agree that it's that green dot right there. Whether you know it or not, that's the vertex of the parabola. And as you see this start to take shape, you'll say, well, that really actually makes a lot of sense that it would be. So if you go from the focus and you go straight up or down to the directrix, halfway along that journey, you're going to find the vertex of your parabola. Now, what happens next is the interesting part. And I use the term interesting a little bit loosely, but take a look at like this next green dot right here. For you to understand, if this time is not wasted, then you'll understand what I'm about to draw. Would you be okay if I said that that red line segment is about the same length as that purple line segment? Do you see that? Would you agree then that that green point is about the same distance away from the red point as it is from the yellow line? Good. Then that's now a point on the parabola. And what happens is as you continue to draw points for which those distances are the same, you're forming what we call a parabola. As you change the distance between your focus and your directrix, you change the general shape of a parabola. I could do another one too. Like I could put another point like out here. And it gets a little bit harder to fudge this, by the way. Like I'm completely just fudging the dickens out of this right now. But like if I tried to stick a point right out here, and I could do this more scientifically, but the point I'm trying to make is just now look at the distance from here to here. And maybe you would buy that if I've done a decent job with my artwork, that those two distances are the same. Do you see it? That's how a parabola technically behind the scenes comes into existence, is that by definition, it always has been, the set of all points in a plane that are the same distance away from some point as they are from some line. So the point again is called the focus, the line is called the directrix. And it's that like sort of loving relationship between the two. Is that purple line crooked? Oh, I can't stand for that. Can I fix this?
Let's get rid of this.
You're not kidding about that. Let's just start over. Sorry if I'm wasting your time, but I could not sleep tonight if I left that thing dangling there crooked. So anyways, all the points in the plane that are the same distance away, and that relationship, by the way, would continue, if you extended it up this way and then shot the next line segment down this way. So as you continue to make that relationship true, then you are uncovering all the points on the parabola. So I don't regret having to show you that, but I think it's important as we go through the next week or two of this, that you understand sort of how things are happening behind the scene. And I'll give you the same sort of clunky, awkward explanation when we get to ellipses as to how does an ellipse work? Like, where does it come from? Why does it have two centers, whereas a circle only has one? Stuff like that. So anyways, that is what a parabola is. It's a set of all points the same distance away from a point and a line. And then, of course, you can see the parabola coming into shape. I shouldn't probably need to draw this, but you get the idea that then the parabola goes like this. Oops, missed it a little bit, but then it would do the same thing, of course, on the other side. You guys remember parabolas from before. Got it. Okay. So that's, go ahead, buddy.
The lines just keep doing longer.
Because as this one goes up here to catch up to the curve, then naturally this one, oh, I meant to make it purple. Do you see how they offset each other? As one of them has to go further away to get to caught up, then this one has to go further away to get back down to the directrix. I'm not sure you're buying my explanation for that. Are you in your own special way calling BS?
Yeah, kind of.
Okay. Well, it's not BS. I mean, that is the definition of what a parabola is. It is the set of all points the same distance away from two objects, a line and a point. And do bear in mind also that when we talk about the distance from a point to a line, we're always talking about the perpendicular distance. So like you're not at liberty to take like this purple one and go down here. Like you can't do that. You understand, Mr. Manlove taught you this in geometry, that distance is always perpendicularly measured, right? So do you see that the red and the purple are the same? This one and this one? I'm sorry that I did a poor job of convincing you, but in time you'll buy what I'm trying to say. And again, if I took that focus and moved it down and took the directrix and pulled it up, is that we call that the focal distance, focal length? As that focal length shrinks, then the parabola is going to be impacted by that in a squishy kind of way. Got it? Okay. So let's get to the meat and potatoes part of this. And I was about to teach this lesson yesterday off of no graph, and I was thinking, man, this is just a dumpster fire waiting to happen. And I was, as I always do, I'm sitting at home and I'm trying to think of like, okay, how can I phrase this? What angle can I give them? And then I thought I would check Delta Math, and I was like, thank you, Delta Math, for having such a wonderful visual sort of representation of this. So for this portion, the first thing I want you to do is write down a couple of formulas. You're going to get probably a little bit mad at me for this, but I can take it. So for the first one, I want you to copy this down. And then I'm going to have you please, if you'd be so kind, on the other side of this red curtain, I'm going to have you copy down another formula for me. So since you guys are pretty smart, would anyone with great powers of observation like to guess what's going to go in that set of parentheses? You're good. Yes. So something that will change today is that in the past, our experience together has always been, not always, but like when we talked about it in the context of like graphing, our parabolas were always like this. We always had parabolas either go like this or like this, right? Parabolas for us always either went up or they went down. Starting today, we're going to see some inverted parabolas. And so um, this first formula right here, and just copy all this down and make yourself a nice little resource cheat sheet. This first formula here is for when your parabola opens up or down. The second formula, you guessed it, is for when your parabola opens to the left or to the right. There's another, by the way, this is just a very standard conic equation. So I'll try to talk to you kind of throughout the lesson a little bit about when do we stop here, when do we move on from here, but sometimes we'll just stop here when we put numbers in place of letters. So for this formula to be any good at all, like at all, it's useless if you don't know this stuff. First off, you need to know that the vertex of your parabola is the point HK. You also need to know that the focal distance is equal to P. And I'll try to conjure up like 4 different examples for the notes today where you get to see a little flavor of each, where focal distances can be positive vertical, they can be negative vertical, they can be positive horizontal, or they can be negative horizontal. And you'll probably want to know right now, you should want to know right now, what is this man talking about? What is the focal distance? And that is the distance from the focus to the vertex. And I would have said the same thing. Like it feels like maybe based on what I've taught you so far, that it feels like maybe it's the distance from that point, the focus down to the directrix, the line. It's not. It's the distance from the vertex to the focus. And I can't say like up to the focus because sometimes the focus will be below. Sometimes it'll be to the right. Sometimes it'll be the left. And this one, put a little comment in here that direction matters. And what I mean by that is if you go up from the vertex to get to your focus, P is positive. If you go down, P is negative. If you go right, P is positive. If you go left, P is negative. Things that make perfect sense to the human brain. Okay. So that should be enough information right there for us to clumsily work our way through a couple of examples. And the thing today is like, again, how far do I want us to go? So we'll talk about that. Delta math you'll see when I pop over to it in a second. Delta says you can put in your answer in any format you want, which is nice. It's going to encourage us though to stop and never experiment with the general form of a conic. So the inclination is we want to get the first one we see, type it in, go to the next problem. But I would encourage you to experiment and try to move on and try some other flavors. And I'll show you what those other flavors are. But for now, if everything goes as fingers crossed it should, this format right here up at the top of the board will be okay. All right. And again, that's just a general, or that's a standard conic equation.
All the stuff that we just wrote down is good for both sides.
Yes, it is. So that I only wrote it down once over here. Really, what I should have done is probably split this and written it in the middle. Here, watch this. I got you there, fam. You ready? You're welcome. What's that? I know. Get good, noob. Yes, it applies to both sides. So what you really need to know is what, and you'll see once we put this into practice, you'll be like, that looks weird. It's not bad. If you know the vertex, you can pop them in place of H and K. If you know the focal distance, you can pop it in place of P. And it doesn't take long just to say, boom, I'm there. Like I've got it. And I just don't know today if I want you to move on past that or not. So let's see how this goes. Let's see if what's about to happen makes any sense at all. So I believe in you guys, though. I think you got this. I'm sorry that in this part of the lecture, you're going to have a hard time keeping up with me because I have an advantage in that I've got some pretty specific stuff up here that you probably would have a harder time sketching onto your notes. So, but that's not to say that you couldn't try. It's up to you. So I'm going to zoom in on this a little bit. So this assignment, I was about to do it, like I said, without the aid of a graph, and I was really struggling with how to get it into the most condensed and easy to understand format. But you'll love this. Well, you'll appreciate this, I think, how easy this is. So first off, the focus is up here at 111. The directrix is a horizontal line down here, y equals 3. Where's the vertex going to be? Did you get that out of all that talking I just did?
7.
Be more specific.
1, 7.
Yes. So did you take away from that, if you were able to decipher any sort of meaningful information, that the vertex will always be halfway between the focus and the directrix? Good. So the distance between the focus and the directrix is just basic math. This is at a height of 3, this is at a height of 11. That's a difference of 8. Split the difference is 4, which means the focus or the vertex, it literally has to be right there. So as you're doing these problems today, the first thing you want to do is write that down. 100% you want to write it down and say the vertex is at 1, 7. And what's important for you to understand is that 1 and 7 are two letters essentially that are going to go into our formula. What's 1 going to take the place of?
H.
Good job. Good listening. H, and what's 7 going to be?
Okay.
Nice job.
And then we're-
So you want to make sure you have the correct formula, since this is obviously, and maybe I shouldn't say things like that, obviously. Based on the lesson so far, I hope you agree that the parabola opens up like this. Do you? It's always going to open away from the directrix. And so if the directrix is a horizontal line down here, the parabola is going to open up or down away from it. And so we're going to choose the vertical formula, which was the first one. You wrote it down on the left side of your paper. And all we're going to do now is we're going to change some numbers into letters, but we're going to get to one of them, and we're going to pause a little bit when we get there, just so we can talk about it. But the first part of this we can fly right through. So the first thing you wrote down in your formula was x minus h squared. For us, that's going to say x minus what? X minus 1 squared. Beautiful. And right away we hit a wall. There's a new guy. What's p? 4. Good. And it is positive 4, just for the record. It would matter. And I'll try to, like I said, I'll try to show you like a mixed bag of examples. But in this case, P is positive 4 because the focus is 4 units above the vertex. And so that tells us that the P value, the focal distance, is 4. Okay, so the next thing you encounter in the formula is 4P. And what's that going to be? Yes. So we have 16. And then what's the next thing? Yes. And this is the part where honestly, I could go to the bottom now and I could type that in just like that and it would accept it. It says right there in any form. I don't know if I like or I hate that. I wish they would have given me the ability to sort of do like 5 where you have to do this and 5 in general form or whatever, but it'll take whatever. So if I went to the bottom and I just typed that in exactly like that, it would take it. Where we're headed with this eventually, I kind of want to get on with this lesson, so I don't want to belabor this point, but where we're headed eventually is we're going to take this equation and we're going to start monkeying around with it. We're going to square, multiply, double this out. And eventually it's going to lead us into the general form of a conic, which you don't have to write down today if you don't want to. But it would be ax squared plus bxy plus cy squared plus dx plus ey plus f. And that looks a lot worse than it is, don't worry. But the nice thing about the general form of a conic is that when all is said and done, if God forbid we make it through parabolas, ellipses, and hyperbolas, everything can come back to this format. That's why it's called general form. Like your ellipse, your hyperbola, your parabola, all conic sections can have their equations written like this, which there's something to be said for that. But I've decided just now that we're not going to go down that road today. So for us today, what I have in the purple oval is an acceptable answer. And it's not hard at all. So let's find another example. I'm going to erase this and I'm going to go to new problem. How about this one? Where's the vertex? Oops, you don't really need the information. So there you go. But yeah, so where we're going to go with this soon is I'm not going to give you the graph. I'm just going to give you the focus and the directrix. And you'll have to kind of like, you can graph it if you want. But like you'd have to do that on your own or try to figure out in your head how to figure out where the vertex is. In this one, where is the vertex?
6.
I'll take it. Good. So the vertex has to be halfway in between the focus and the directrix. Which way is this parabola going to open? Downwards for sure. Again, the directrix is essentially like the blocker in the back that like blows on the parabola and forces it to go the other way. Like it's a big like vent, right?
It like opens up the be vertical.
Nailed it. Yeah. So this parabola is going to open down something like this. Who knows what the scaling of it is? You'd have to work that out, but that's not what we're going for here. So the coordinates of the vertex you said are 6 and 0. So 6 is going to replace h, 0 is going to replace k. And since it's a vertical parabola, what are we going to start with? What's p? P is -5. Yes. So I wanted to make sure that I chose some with negative. I know you were getting ahead of me there, Coop, but can you all see how to go from the vertex to the focus? You have to go down 1, 2, 3, 4, 5, that focal length in this case. And that's why I said direction matters. So in this case, P is not 5, but rather -5. So the next thing we write is going to be -20. And then what's going to be in the second part?
Times one.
Times y minus 0, which means you can just put y and you're done. Okay. If I had, it will accept that answer. Should we try it? That's fine. Yep. And now I want to get you a couple of horizontals, and then I know I've just killed you with, I can see you just dropping like flies. So let me get this done. I have to go back. I don't know why they call them level 2. It's not like they're any harder, I don't think, but here's one. So you see how the directrix, the blocker wall, is on the left this time, and it's a vertical line, so it's going to force the parabola. Which way is this parabola going to open? To the right. Very good. And where's the vertex going to be? 7, 3. Like this is why having the graph helps so much. Trying to figure out those coordinates when you don't have it is like it can be like a little bit of a mental puzzle, but when you see it, it's like, well, there it is. So the vertex is at 7, 3. And let's do this. So since it's a sideways now, we're going to hop to the other side of our notes and we're going to do the other equation. So you okay, Aiden?
Yeah.
Okay. I know it's hard to get these in your notes, so I apologize. What's the first thing we do for a left and right parabola?
Y minus k squared.
Y minus k. What's that going to look like for us?
Y minus
Y minus 3 squared equals. What is my focal distance or my focal length this time? My p-value is what I should say. That's +3. And the reason is because, again, it's opening to the right. And so the focal length is directional sensitive. And so we're going from, see if you can follow this little purple arrow here. We're going from vertex to focus. And that's why vertex to focus is going to give you your focal direction. So focus in this case is over here. So the focal length is +3. So P in this case is +3. And then you're going to just go over here and do some math. Now that you know what P is, what's the next number you're going to write? 12. 4 times 3. 12. And then in parentheses, what do we put? None. And there, if I had all the time in the world, there's so many interesting things that you might not think are interesting. We could manipulate that and make it look like the parabola equations that we're used to from olden days, but you probably wouldn't get all geeked up about it. Let's do one more, except this time let's find one that opens, of course, to the left, and then I'll shut up. I gotta zoom out. This is driving me nuts. Yeah. Nope. Oh, look at this guy. I wish I could do a good crocodile hunter impersonation. I'd call it a beauty, but I can't. All right. So last of the flavors, parabola opening to the left. Where's the vertex, first of all? How far? I'm sorry. -2, 2, right here. That sure looks correct. What's that total distance? 14, 7. Love it. Perfect. So the vertex is at -2 and 2. Love it. And so let's do it. We're going to use our sideways formula. So what's going to be the first thing we write?
Y minus 2.
Y minus 2 squared equals. What is the p-value this time? Good for you guys. P is from here over to here. Since it's leftward, it's going to be a negative. So P is -7. So we're going to slap. What number goes right here? And then in here?
X minus, well, X plus 2.
Good for you. Good catch. X plus 2. You got it? Got it? Rad. You guys ready to try some? I'll take that as a yes. It's on Delta Math. So you get to do it like this. I'm so excited to find this because this is really going to be a calm and success-oriented introduction into conics. I think you're not going to struggle with this. But tomorrow I'm going to pull the rug partially out and we're going to take away graphies. Bye-bye pictures.